Hi guys, it's Dan Bentley. I'm one of the HL math teachers of Section D, and I'm just going to give you some general feedback on that automated quiz that you guys did last week. Okay, I think I'm just going to pick three of the questions that it seems like a lot of kids struggled on. So the first question was question 2. So you've got two functions, f and g, and they're defined as follows. And then you are asked to do g of f. There's actually, this didn't come out but it's sort of a g of f at 4, and so this is a composition. So you're actually putting one function into the other. So I'm going to do this two ways. So what I've done here to start off is I'm actually evaluating f at -4 at inside the function g of f, or inside the function g. So okay, so now as I've evaluated f at -4, I get -7, and now I'm plugging -7 into the g function, and so there we go. I plug wherever I saw x, I just put in -7, and it worked through to 16. Excuse me. A second method might be to actually find g of f at x, and then plug -4. So you look here, if I actually plug one function into the other, and I'm going to simplify it, and there is my g of f at x. So that's my composed function. Okay, so now I'm just going to put -4 in for x in this function. And if I do that, then I will hopefully, -24, get down to the same answer. So I've kind of got a second method there. Either way is fine. Some people prefer working just with numbers. Others like to kind of manipulate the equations using the variables in the general case first, and then plugging in the number after. That both is fine. The next question was question 7. And so here we've got our two functions, h at x and k at x. And then we're asked to find the value of c such that h evaluated at k at x equals 0 has equal roots. Okay, so if I begin by actually plugging k at x into h at x and simplifying this and cleaning it up, I get that. And now it's talking about roots again. So whenever I see something talking about roots, I always think of the discriminant. So here it is. The discriminant, it has to equal 0, right? So that's if I have equal roots. So you remember that from the last chapter. And so b squared minus 4ac has to equal 0. I do the algebra. I work it through. And I get, there we go. So in lowest terms, 5/48. Okay, so we're kind of combining two things, a composite function there, and then also our discriminant as well. And the last one was question 9, which is a trickier one. So we're talking about domain and restricting the domain for an inverse function. Okay, so a few different ways to approach this. I kind of looked at this. I saw that's a quadratic. So I completed the square to get this in vertex form, so I could see what that graph looks like. So I know my vertex here is 2, -6. So I could graph that. There's my vertex or turning point. And if I graph this, I've dotted this left side for a reason, because this needs to be a 1-to-1 function if it's going to have an inverse. So I don't want that other part of the function there. So anyway, so since I don't want this part of the function, I'm going to restrict the domain. So I restrict the domain to x is a set of all real numbers, okay, where x is greater than or equal to 2. Okay, and that comes from my vertex there, the x value of my vertex. So I mean, that's the answer to the question, but just to remind you, remember, a inverse function is graphically flipped over the y equals x line. Okay, so if you think about that, and then all of my points, my vertex of 2, -6 would become on the inverse 6, -2, and that graph, all these points on here would be flipped, and you kind of have a mirror image over this y equals x line. That's just sort of, that's not what they were asking for. They were just asking for the lower bound of this domain. Okay, but anyway, that's just a little reminder of graphically what the inverse function is. Okay, guys, I hope this helped, and that's all for me. Okay, take care.